Welcome back. In this video, we will cover the calculations for our casing design. The first one will be the surface casing depth. And for that, we'll need two informations from these tables, as well as the TVD of the bottom of the first intermediate casing that we got on our density versus depth graph. We need the highest pressure gradient from a reliable measurement near the well. In this case, we cannot use loss circulation data nor the kicks because those are not measurements, and we cannot use this estimate table 2. So we end up with static gradient and the buildup. After calculating the gradient for these points, we can see that the buildup is higher, so that is the point that we will use for our calculation. The other information from these tables is if there are water wells close to the one we will drill. It needs to be closer than 200 meters, so just the first one will be considered. Now on our surface casing depth calculation form, the final depth of the casing will be the highest number between three calculations we will make. First one based on the water well search, the second based on the highest pressure gradient on the area, and the third based on the total length of the well. First we need the total length, which will be 3680. Next, from our input tables, the depth of the deepest water well within 200 meters, and this will be 15.24 meters. Adding 25 to that, we have our first calculation done, and the result is 40.24 meters. For the second calculation, we need that pressure measurement that we got from the buildup. The pressure is 38,663 kPa. The depth is 3,270, and this is the UWI of the well. We got this information from. We add the pressure gradient that we calculated in there, which was 11.82, and then use this formula since we only have one zone. Now we do the second calculation for the surface casing depth. In this formula, the required TVD is the bottom of the first intermediate casing, the one we got from the bottoms up method on the graph. In this case, in my case, it's 1,830 meters. And the result for this calculation will be 379 meters. The third one is simply 10% of the well total TVD, and that is 368. As our second calculation gave us the deepest of the three, that's the one we are gonna use as the surface casing depth. Now we need to calculate burst rating for the casing 139.7 and tension for the casing 219.1 and collapse for the 339.7. First thing to do on the burst calculation is to convert outside diameter and inside diameter of the casing from millimeters to inches. We just have to divide it by 25.4. And now we calculate the casing wall thickness subtracting OD from ID and divided by 2. We then use the burst calculation formula, which is 0.875 times 2 times the yield strength of the casing, which we can get from the grade. divided by the outside diameter in inches. That gives us 14,525 psi. We round that up to the next 10 psi and then convert it to metric by multiplying it by 6.89476, and the result is 100,181 kPa or 100.2 MPa. That's our result for the burst. Next is the tensile calculation. Convert OD and ID again from millimeters to inches. But in this one, we will correct the outside diameter to the nearest 1/8 of an inch. Then we use the formula pi/4 times the yield strength again, which we can get from the grade of the casing. All that times outside diameter squared minus inside diameter squared. And that will give us 317,877 pounds. We then round it up to the nearest 1,000 pound and convert it to metric by multiplying by 0.453593 times the gravity divided by 10,000. And the result will be 141.5 kilodecanewton. So that's our answer for the tension of this casing. Now for the collapse rating calculation, convert the diameters again to inches, correcting just the outside diameter to the nearest 1/8 of an inch. Calculate again the wall thickness. Calculate dn/t, which is the outside diameter divided by the wall thickness, and then look up on the tables to see what kind of collapse we have. For the J55 and the dn/t that we have, it is transition collapse. We then use the formula for transition collapse, which is the yield that we got from the grade times the F4 from the table, 1.989, divided by the dn/t, all that minus the F5 from the table, which is 0.0360. The result is 1,128 psi. We again round it up to the closest 10 psi and then convert it to metric by multiplying it by 6.89476. And the result is 7,791 kPa or 7.2 MPa, which is what we put on our table as a result. We can now move on to the casing selection chart, as our production casing is 114.3. The only choice for intermediate casing is 177.8, and then for surface casing 244.5. But if we have the choice to pick up another casing, we need to go with the lowest number. For that will give us a cheaper casing. After selecting the casing's OD, we need to calculate which weight and grade from the ones available we have to pick. For the surface casing, I assumed 390 meters, as my calculation gave me 379 meters, but we need the multiple of 13, so that's the next one. From Directive 010, our surface casing burst is 5 times the next casing depth, which is 1,830. The collapse is 11 times the surface casing depth, in my case 390. and the tension is the design factor times the casing weight times the casing TVD times gravity divided by 10,000. So checking the casing burst, it is higher than the one we calculated. The same with collapse and the same with tension. So this casing 244.5, 48.07 kilograms per meter, H40 STC has enough burst, collapse, and tension ratings, so we can use it. We do the same with intermediate casing, but the burst for it will be the highest measured pressure in the surroundings. So as we saw before, 38,663 kPa. Collapse and tension are calculated the same way as before. So looking at the burst, we can see that we cannot use the first four casings listed, for they have a lower value than the one we calculated. Let's check the next one. So burst looks okay, collapse also good, and tension is way bigger than we calculated. So this one, the 177.8, 34.23 kilograms per meter L80 LTC is the one we will use. Finally, for production casing, burst is the same as the intermediate casing. Collapse is the mud gradient, which is the mud weight times 0.00981, then times the production casing TVD. Tension is calculated on the same way as the other casings. Um, Now, looking at burst in our table, we cannot use the first three, um, but we can use the fourth. Checking for the collapse, it's lower than what we calculated, so let's check the next one. Burst is okay, as is collapse, and tension is okay too. So that's the one that we will use. 114.3, 17.26 kilograms per meter, P110 LTC. And then we just need to draw a simple diagram of the casings, inserting its depths on the left side of the casing and the labels on the right side. Don't forget to go back to the density versus depth graph and add the casing string on the right, showing the casing depths. I hope this video will help you on your test. So see you there.